All right, we're going to continue building here. We're building up towards something called slope-intercept form. We've talked about slope. We've talked about finding the x and y intercepts. Now we're going to use some of this information to help us. We're not quite to that point where we can write some equations, slope-intercept, but we're going to start combining some of these ideas together. So we've talked about y-intercept, x-intercept. We've talked a little bit about slope with rise over run. Now we're going to find the slope, given some graphs, given some different points. And so we did this already where you're given a graph, find the slope. Slope is rise over run. So I'm going to write that down here. Slope is going to be, and slope we're actually going to refer to as m. So the slope is going to be rise over the run. Why is it m? I don't actually know. But rise over run. And so rise over run, we're going to figure that out. So if I look at my points here, the rise, I've got -5, and 3, 2. So from -5 up to 2. So from -5 up to 2, that's 7. You could count. But really, if you do from -5 up to 0 is 5, and from 0 to 2 is 2. So from -5 to 2 should give us a rise of 7. The run. So again, from -5 to 3, without even counting, we should know that from -5 to 0 is 5, and from 0 to 3, that's another 3, which gives us a run of 8. And so we can use those numbers to help us figure out the rise and the run. And this would be a positive slope because it's going up from left to right, and so it is a positive 7/8. So that would be the slope. All right, let's use that same idea here. If we're not given a picture, we just have these 2 points. We've got a line that contains these 2 points. It's got a whole bunch of other points on the line, but we know these 2 points are on the line. And we're going to try and find the slope of this line. So if we think about the rise between these 2 points is going to be, right about there, the rise between these 2 points is going to be the y values. Rise is the y. The y values creates that rise. And so the y values, 5 and 1. So what is the difference between 5 and 1? The difference between 5 and 1 is 4. So it rises 4. From 5 to 1, it goes down, I guess, in this case, 4. So the rise would be 4, -4. From 5 down to 1, -4. It goes down 4. The run then, well, that's on your x-axis. So if we look at the x values, if we look at those x values from 2 to 8, well, from 2 to 8, it runs 6. And so the slope, again, if we reduce, we would divide by both of them by 2, we get -2/3. That would be the slope between those 2 points. And you could draw your picture, if this was 2, 5, and this was 8, 1, the slope of that line would be, it would go down 4, and it would go over 6, so that would be 6, that would be 4, and there you go, you got your -4/6, -2/3 as being the slope. We're going to put that into a formula. This formula is going to help us speed up that process. And really, it's the exact same thing we were just doing. We're saying, well, what's the change in the y's? What's the change in those y values compared to what's the change in those x values? Rise is the y, x is the run. And so our slope formula is going to be, again, m. We don't know why m, but m, that's the slope. M is the slope. If we have 2 points, if we have 2 points, x1, y1, x2, y2, which we just had a minute ago, we've got 2 points, x and y, we can find the slope of the line that goes between those 2 points by finding the change in the y values, subtracting those y's, which is what we just did, y2 minus y1, compared to the change in the x, x2 minus x1. So if we have 2 points, not squared, now you'll notice that they're not squared, we have 2 different x's. We've got x1, and x2, so we subtract the x's for our denominator, that's the run. We've got y2 and y1, We've got two different y values. We're going to subtract those y values. That's the slope formula. Let's try it. Okay, so I'm going to write that slope formula down. M equals y2 minus y1 all over x2 minus x1. Okay, so here is y1, here is y2, and it doesn't actually matter which one is 1 and 2. I'm using 1 and 2 just in this order. It doesn't really matter which one's 1 or 2. As long as this is our first point and that's our second point, we're good to go. So I've got my x1, y1, x2, y2. I'm going to plug this into the formula. Okay, so formula says we do y2 minus y1. So negative 2 minus negative 2. x2 minus x1. So 7 minus negative 2. All right, we do the math. Negative 2 minus negative 2. If I subtract anything from itself, I always get 0. 5 minus 5, 8 minus 8, negative 2 minus negative 2, it's always 0. 7 minus negative 2, well, I'm taking away a negative, which is like adding, and so I end up with 9. 0 divided by 9, the slope is 0. If you actually plotted those points, you would see the same thing. Negative 2, negative 2, 7, negative 2. It's going to have a slope of 0. And so we got that slope formula. Give these two a try. Pause it. Try and find the slope for the first one. And then I'm going to challenge you. Use the slope formula, exact same formula. Use the slope formula to figure out what, and I haven't changed it here. I made it actually a little bit easier for you. Figure out what y is. So solve for y in this problem. All right, I'm going to assume that you paused, and I'm going to assume you tried it on your own. The slope for the first one, m equals 3, or you could have 3 over 1. I did tell you that we like to have an improper fraction, rise over run, and so 3 over 1 is perfectly great, but if you wrote 3, that's just fine as well. For the second one, if you solve for y, you should have gotten that y equals 2. Now again, if you didn't get either one of those, or if you have no idea how I got that second answer, click the linked video, watch how to do it, try the form questions below, and then we'll see you in class.